Okay, in this video then we're going to look at more complex problems involving cylinders, spheres, things like that. We're going to look at a thing called recasting. Okay, recasting just means we have a certain shape and we change it into another shape basically, right? The secret of this is whatever shape we have, we get that formula down, we let it equal the shape it's going to become, okay, or the shapes it's going to become. So if we look at this, we have a cylinder, it's metal, it's melted down, it's recast into 5 spheres, all equal size. Find the radius of the spheres. Now what we have to remember is, if we melt this down and change it into 5 spheres, its volume doesn't change, the amount of stuff in it doesn't change. Therefore, I can let the two formulae equal each other, right? So I can say what the formula of a cylinder is pi r squared h. So the volume of that will equal the volume of this, which is 4/3 pi r cubed. But remember how many of them is there? There's 5 of them. And that's the volume of those, right? They're going to equal each other. Because remember, I'm going to melt this down and make 5 of those. So volume doesn't change. Alright. And all I do now is fill in what I know. This is what I don't know. This radius, this is what I want, right? And I'll use a bit of algebra to find that. So, first of all, in something like this, generally I'll leave pi as it is, because generally it'll cancel out. Okay? So we leave pi. We know what the radius is. It's 5 squared. We know what the height is in this. It's 10. 4/3 multiplied by pi multiplied by the radius cubed multiplied by 5. Okay. I get rid of my pi's, so 5 squared is 25 multiplied by 10 equals 4/3 multiplied by radius cubed multiplied by 5. And that would give me 250 equals, I suppose we can multiply the 5 and the 4/3, so 4/3 multiplied by 5 equals 6.66, right, so 6.66 multiplied by radius cubed. Okay, divide this by 6.66, divide this by 6.66. 250 divided by 6.66 equals 37.53. That equals the radius cubed. Get the cube root of that. We'll just be left with the radius, which is what we want. Get the cube root of this. So let's do it. Cube root of 37.53. So cube root 37.53, and that equals 3.3. Okay, so that's how that's done. Similar one here. So let's sketch this out. It says a ball was dropped into a cylinder of water. How much will the water rise when the ball is dropped in? Okay, I'm going to draw it out, right? And I'll give you the measurements. So let's say this ball has a radius of 5 centimeters. We have a cylinder. It's so much full with water. We don't know how much, but so much full of water. So sorry, 1 second. Just say up to here. Okay, and we'll just say the radius of that cylinder is 7. Right. I better make this ball a bit smaller, I guess. Radius equals 2, we'll say. Right, the ball is dropped in. So there's the ball, and it goes in here. Now, whatever the volume of that ball is, when it goes in here, the water is going to rise by whatever the volume of that ball is. Okay, so whatever the volume of that ball is, the water will rise by that volume. There's a story about it with Archimedes, how he was asked to find basically the volume of a king's crown. Okay, this is the very short story. There's the shorthand version of it, but he was asked to find the volume of a king's crown because there was a thought that a blacksmith might have taken some gold, and Archimedes wondered how could he find the volume of the crown without actually melting it down. And one day he filled up his bat to the top, and he got into the bat, and when he got in, the water, I suppose, spilt out, and he got out of the bat and he started shouting, "Eureka, Eureka," which means "I've got it." And because he realised the water would have rose the same amount of volume as whatever was put into it. So if he could do the same with the crown, well, then he'd be able to find out the volume of it. Same with this, really, right? Anyway, back to the question. So we take this ball, we put it in, what volume does it rise? Right, well, I could find the volume of this very easily. The volume of a sphere is 4/3 pi